Hey, boys and girls, we will continue our lesson.
Last week we stopped at this lesson number 22 is about power. Okay, before we start power, we recall a bit about power, what we have learned. Okay, we learn about work done. Okay, work done. Work done is the energy lah. Okay, energy transfer. So at here, work done, rate of work done. As I told you last week, rate is meaning that per unit time. Per unit time. Okay, sometimes the IGCSE question, they don't tell you that calculate power, but they say that calculate rate of work done, rate of energy transfer. They might be saying so. So meanings that they are asking you to calculate power. Okay, they are asking you to calculate power when they're mentioning about rate of work done or rate of energy transfer. Okay, because this is the definition. Okay, work done per unit of time is power. Energy per unit of time is power. Okay, so at here, if let's say how we increase the power, how we consider the power is high power. Okay, I take some daily example lah. Okay, example. So let's say you're doing the homework. Now I giving you 5 homework. Okay, so you doing 5 homework. Okay, but your friend only doing 3 homework. Okay, this is work done. You do work. Okay, it's not the energy lah. I just simply take some example to let you see the difference lah. Okay, if let's say you do 5 homework, your friend doing 3 homework. Okay, per day. Okay, or per hour, whatever. Okay, so the one do more work. If you do more work, then your power will be higher power. Okay, if you do more work compared to others, you do more work. So this one work done increase, power will increase. Okay, can you see that? Then if let's say you and your friend doing the same work. Okay, fine. Let's say 5 Joe. Okay, so easy to imagine 5 homework. Let's say I give 5 homework. You and your friend complete 5 homework. Okay, both of you complete 5 homework. But the problem is you using only 1 hour. The time is 1 hour. Your friend using 24 hour one day. So who are the one more powerful? Okay, with the 1 hour, which is the shorter time, actually more power. Okay, so at here, if you divided by the time, if this time is lower, shorter time, you can complete your work in a shorter time. That means that high power. Okay, so I repeat, how you increase the power? Two way. One of the way is maybe you do more work. You do a lot of work compared to others. You do more work, so you are more powerful. Or you're doing the same amount of work, but you do it and complete it within a short time. So the time is short. So at here, power will be high. Okay, so this is about power. Power unit is what? Or based on the formula, if let's say in the exam you forget, what is the unit? It's okay. You can derive it. Energy in joule, time is in seconds, so it's joule per second. Okay, power no direction, because energy no direction, time no direction. So power also no direction. Okay, so no matter how, please remember the time have to convert to second. Okay, 1 minute 60 second, 1 hour is 3,600 second. Okay, so this is about power. Then after that, we learn about the efficiency. Okay, efficiency, the symbol is not n, it's slightly got a long tail, something like that. Okay, so at here, uh energy useful output, this must be useful. Okay, this must be useful output divided by input times 100%. This is efficiency, how efficient. Okay, must be useful. Sometimes the question they give you wasted. Okay, then how should we do? We should using the total input minus the wasted. Then I know that the rest is actually useful output. Okay, then calculate efficiency. It can be in energy divided by energy or power divided by power. You will get the same answer. Okay, you will get the same answer. So that day I got mentioned E over T divided by E over T. The T and T can be cancelled. So actually they will be getting back same answer lah. Okay. So that day we stop at here exercise. Okay, now here. We look at the page number 9, question number 6. Okay, that day we stop at here. Then question number 5 is very important questions. It's not like reading the question, then find the value, put in formula, cannot. You have to think in overall picture, okay? So for question number 5, small hydroelectric power. So this one is power, hydroelectric power station. So water will be stored at here. This is your input. So in your idea, you must understand that this is your input. Then input is mgh because water stored behind the dam is mgh. Then after that, water will flow, turn the turbine, turn generator, generate electricity. So electricity is your output. You have to read the question and think overall picture to find out what is your input and output. Okay, find your input, find your output. Okay. Okay, so we look at question number 6. Two cars P and Q have different engines. The input power from the fuel is the same for both engine. The engine in car P is more efficient. Okay, so car P is more efficient than the engine in car Q. Okay, which statement about the car or their engine must be true? Okay, read A, B, C, D, and then you choose what is the correct answer. Then you type in the chat box to me. Okay. Car P more efficient. A is saying that car P has higher maximum speed than the car Q. Car P has lower maximum speed than car Q. The engine in car P use less energy per hour than the engine in car Q. The engine in car P wasted less energy per hour than the engine in car Q. So what is your answer? Angeline, yes. Okay, how about others? Type your answer in the chat box. Zihua, yes. Kristen, no. Efficiency is related with what? Energy, useful output, divided by energy input times 100%. Okay. So, Crystal, you think again? What is the correct answer? Efficiency is related with the energy or power. Okay. If you're using power, then bottom part also power, input power. So, you try one more time. What is the answer? How about others? Xuan, Megan, Emily, Hui Tong? Megan, correct. Crystal, correct right now. Okay, deal. Answer should be donkey. If more efficiency, that means that this one is high. High efficiency. If high efficiency must be useful output more. More useful output energy. If more useful output energy, for example, this one is 100 joule. So I got 80 joule is useful. So my wasted one will be the 20 joule wasted lah. Okay, so if let's say high efficiency, that means that this useful maybe more than 80, it become 90 joule. So your wasted become 10 joule decrease. Okay, so at here, engine in car P waste less energy. Yes, because waste less energy, meaning that in another way we can say that is more useful output energy. More useful output energy. Okay, these two is the same meaning. Less wasted energy, that means that more useful output energy. So answer should be donkey. Okay, A and B we don't know. Okay, C and D. C is use less energy per hour. Use less energy, no. Why no? Because input power is the same. Their input power is the same. So they're using same input energy. Okay, so C is wrong, D is correct. Okay, can we go to page number 10, question number 7? Crystal, okay? How about others? Zihua, okay? Okay, yes. Megan, okay, okay. Dear, here question number 7. This is the energy into and out of a machine. Okay, can you write an equation that link I, U, W? How you link these three? I, U, and W. I equals to U equals to W. W equals to U plus I. Or U equals to W plus I. Or I equals to U plus W. Angeline, correct. Okay, others also give me response so that I know that you understand about the part. You have to respond to me. Okay, input here is the total. Okay, then it will equals to the output, total output. So our total output is from the useful and the wasted. So it should be I equals to U plus W. Okay. Okay, if you say U, teacher, can I say U equals to I minus W? Can. Actually, you just rearrange only. Okay, no problem. So, 子花 I equals to U plus W, correct? Megan, correct. Okay. So next, which of these three quantities needs to be as low as possible in order to keep the efficiency of the machine as high as possible? I want my machine is high efficiency. So IUW, which one I should keep as low as possible? Zihua, okay. Angeline, correct. How about others? Try. Okay, we want high efficiency. Again, efficiency is the energy output, useful output
divided by energy input. Okay, so at here we want high efficiency, energy useful
must be high. But now the question asking you what must be low. That means that in opposite way is the wasted energy. Okay, wasted energy W. Okay, so we goes to the next question. The machine gets older and part of it become more. Suggest what is likely to happen for the same input energy I. Okay, input energy is the same. But now the machine is already old. Okay, what happened to the useful energy output? What do you think? The useful energy output. Crystal, okay, correct. Angeline, correct. Zihua, C1, correct. Okay, the useful energy output, it should be decreased. Less, no problem. Okay. So here decrease because it's become old already. The useful energy output will decrease. So at the same times, I told you these two they are related to each others. One high, another one will be low. Because useful energy output decrease, that means that wasted energy should be increased. Okay? Should be increased. How about the efficiency, dear? How about the efficiency? Correct, Angeline. How about others? Try. Machine gets older. What happened to the efficiency? Yes, Crystal. Of course, it will be decreased. Okay, that's why people need to buy a new machine. Old machine getting worse and it produce less useful output energy. All the energy, most of the energy, it will become wasted energy. So it become low efficiency. Okay, so any question for this page 10? No question, then we are going to the next page 11. Crystal, okay?
Only Krista? The rest of you okay? Zihua okay? Megan okay.
Okay, Angeline, okay. Okay, dear, here figure 4.1 show a small wind turbine used to generate electricity. Okay, so the wind blow, turn the turbine, turn the generator. So at the end we get electricity. Okay, wind turbine drive an electric generator. Yeah, you see, turn turbine, turn generator. This one we learned already in the energy resources part. Okay, the wind blows with a velocity of 7.0 meter per second at right angle to the plane of the turbine. Okay, so velocity is here. This is v. Okay, the mass of A passing per second through the turbine is 6.7 kg. This one is m. Okay, here seems like two information, but actually no. You need to read the questions carefully, and here actually still got one more information per second. Okay, 1 second. Every 1 second is 6.7 kg. Okay. So ask you to calculate the kinetic energy of the air blow through the turbine per second. Per second. 1 second, what is the kinetic energy? Okay, can you do calculation? Angeline, correct. Do not forget formula, substitution, final answer with unit. The rest of you try and then tell me your answer. Don't tell me that you forget what is the kinetic energy formula. Sihua, Crystal, Megan, tell me the answer. Crystal, make it two significant figure or three, 2 to 3. Three lah, make it three. Zihua, okay. Okay, so boys and girls, here is 1/2. The mass is 6.7. 1 second is 6.7. Okay. Then after that, the V is 7 square. Don't forget, the square is for the 7 only, not for others. Okay, one more thing is you have to be careful is the mass must be in kg. Okay, why? Because energy is in joule, SI unit. So V and M must be in SI unit also. So your answer should be 164 joule. Okay, 2 to 3 significant figure for our IG. Okay, next here, only 8% of this energy is converted to the electrical energy. Can you calculate the power output? Can you calculate the power output of the electric generator? Zihua, let me check. What is the unit, Zihua? Unit is wrong. Angeline. Angeline correct what? Angeline correct. Okay, dear, you see, this question actually they guide you one by one. Okay, so it might be come out in the MCQ. They don't guide you. Kinetic energy is your input. They cannot. In MCQ, they don't guide you. Input is kinetic energy. Output is the electrical. So it's the same case like just now. What we think about here. We have to think what is our input is the water store. Then at the end, electricity is our output. So this one, if they come out in MCQ, you have to understand what is the input, the wind. Okay, wind blowing, so it's kinetic energy. Then after that, it will convert to the electrical energy. So 8%, that means that is very low efficiency. Okay, so here, Crystal, yes. Crystal, you need. Megan, yes. Okay, here. So we write the formula N equals to useful output divided by power input times 100%. Teacher, I don't have power input. I only have input energy. This is input energy in joule. Kinetic energy is input energy. Teacher, I don't have the power input for power. Then what should we do? Power of input actually is energy input divided by time. Am I right? So at here, teacher, I don't have time. That's why I told you we have to read the question and then find. You see, Not necessary in digit, but they can writing the information in words per second. So that means that at here, 164 divided by 1 second actually is 164 watt. So it will become, here become 164 watt. Okay, power output, electric generator, this part is generate useful. This is generate useful output. Okay, useful output. If the wasted, maybe it's the thermal energy or thermal. So times 100%. So here is 8%. So do you know how mathematics to move it? Okay, 8% divided by 100% times 164 equals to the power output. Okay, you move this to another side, left hand side, and then 164 move to the left hand side. Okay, this is your power output. So your power output should be 13 watt, 13 watt, 13 watt or 13.1 watt. Okay, we will make it 2 to 3 significant figure. So until here, is that clear? Okay, they might be say calculate the wasted output power. So you have to using the 164 minus 13. No, that is wasted. So can you see that this one actually is very low efficiency, only 8%. Okay, so for the wind turbine, what is the disadvantage of we using wind turbine, wind power station? So this one, the output and electricity that we generate is actually small amount. Then how? We need to using a big area of land to build a lot of the wind turbine. We need to build a lot of them so that to generate enough of electricity. Okay, this is a disadvantage. The amount of electricity that can generate by the wind turbine actually is small amount only. So in order to solve this problem, we need more and more wind turbine. Okay. 紫花 low efficiency. Yes. Okay. Any question for this? Here I want to emphasize is this one, the time. Okay, then I want to emphasize this is energy. Here is asking you power. You don't assume kinetic energy. Energy is power. No, energy is energy. Power is power. Energy divided by time is power. But how can the answer still be same? 164 is because per second, 1 second. Okay, so we goes to the next question. Question number 9, dear. Here. Okay, we got workman 1, workman 2. So this is a building project. Workman 1 drops a hammer. Okay, keyword is here. From here drops. Okay. Then after that, drop a hammer which falls to the ground. The hammer has a mass 2.0 kg and is dropped from a height 4.8 meter. Height also. From here, we can know that drop, fall, all these keyword, we understand that the hammer is starting at here, this hammer, what kinds of energy? GPE. Okay, we will get GPE, EP lah, okay, potential energy. So at here, can you calculate the change in gravitational potential of the hammer when it is dropped? When it is dropped, how the amount of the GPE changes until it drop at here. So can you do calculation? Here, GPE is mgh. At the end, at here, when they drop and touch to the ground, actually no more height. No more height, that means that actually this part is no more GPE. So you just calculating mgh. If you want to minus 0, so still the same mgh. Okay? Angeline, yes, correct. Crystal, yes, correct. Zihua, do you able to get the answer? Okay, a lot of students they like to ask me, teacher, change in GPE, right? Okay, EP is equals to mgh. So change in GPE is changing in the height. Okay, change in height. So at here is 2.0 times 9.8 times the changes of height. From here, drop until the ground at here. Actually, this one is 4.8 meter. Okay, the changes of height is 4.8 meter. So at the end, your answer should be 94 joule. 94 joule. Okay. Yes. Okay, we look at the another question here. Can you describe the energy change, energy transfer or energy change from the time the hammer leaves the hand of the workman until it is rest on the ground? Okay, so at here we know that leave the hand at here. So first is GPE. Okay, so we write down gravitational potential energy. Okay, it will convert to what? What do you think? Hammer leave the hand. After that, what energy will start to have the energy? What kinds of energy? Crystal, correct. Kinetic energy. Why? It's moving. It's drop. Okay, object drop. It's move. Got motion. So it's kinetic energy. So this one GPE is because of the position. It got certain height. Then after that, the GPE will decreases and kinetic energy will increases, but not yet finished because they say that until it is at rest on the ground. So can you tell me when they at on the ground, when the hammer is at rest on the ground, what kinds of energy at the end we get? Any idea? Rest on the ground. Friction is not the energy, dear. Friction is not energy. Friction is a type of force. Against the motion is a type of force. So what kinds of energy at the end it will lose to the surrounding? Zihua correct. Answer is thermal energy. Thermal energy, okay, lose to the surrounding when it stop. Okay, can we go to the last page? Question B. Until here, okay? Megan, okay? Xuân Xuân. Crystal, okay Huy Thông, okay? Emily Huy Thông? Okay, we go to the last page here. We talk okay. Workman to pick up the hammer and take it back up the ladder to workman one. Oh, okay. He climbs for the first 3 meters in 5 seconds. His total weight, including the hammer, is 520 Newton. Can you calculate the useful power which his legs are producing? Can you count? Angeline, yes, correct. Useful power that his legs are producing. So power is actually E over T. If you are Chinese, I told you how to remember, right? E, P, T, P, T, P, T, okay? Running nose. So E, P, T, okay? So at here, power is actually E over T, or we can remember E equals to P, T, P times T lah. Okay, so at here, the energy, what kinds of energy? Okay, so if you climbs, okay, that means that is position, a certain height, okay, it will have certain height. So that means that this energy actually is GPE, is GPE. So which is mgh over T lah. Okay, teacher, I don't have M. I don't have M. How to solve? Okay, so at here, can you see that 520 Newton? This is the weight, W. W equals to, W equals to mg. So at here, this one is the weight. This is the weight, 520. Okay, the height at here, climb with 3 meters. So this one is 3 divided by 5 seconds. So your answer at here, 312 watt. 312 watt. Answer should be 312 watt. Is there any question? Any question, dear? Crystal, okay? Only Crystal. Megan, okay. Okay, can you guys try question number 2? Zihua, okay. My boys and girls, try with question number 2. In fact, his body is only 12% efficiency. Calculate the rate at which energy stored in his body is being used. Angeline, very good. Yes, you are very clear on what is the input output, and then you understand about here the keyword that I mentioned just now. Most of the students will think that, what is the energy store in his body? Okay, so is it question asking you about the energy store? No, dear. This question asking you calculate the rate at which energy store. Rate at which energy store. Rate of energy. So this question is asking you what is the power. Okay, calculate the power in his body. Okay, so yeah, ask yourself, just now this question, the useful power the leg producing is actually input or output? Ask yourself. Okay, so why you can able to climb? It's because inside your body, you have the energy stored in your body, chemical energy. Then after that, you converting to the motion, okay? So at here, again, not again, okay, here, producing, meaning that output, we can also understand as this way. Produce, we produce the power. So this is the output. Actually, this is output. Okay, so at here, N is useful output divided by input times 100%. So we only got 12% equals to the useful output. We got 312 watt. Okay, the input we don't know times 100%. Energy stored in his body actually is the input. Okay, this is input, input in the body, and then this inside the energy stored inside our body will be transferred to the output, our motion. So if you do it correctly, if you know how to convert, mathematic convert, okay, divided by 100% equals to 312 divided by P input. Okay, so this one is 0.12 equals to 312 divided by P input. Why I need to do so in detail is because maybe some of the students, the mathematic algebra is not that good, so I have to show lah, okay? So at here, 0.12 times P input equals to 312. So P input equals to 312 divided by 0.12. So if you do it everything correct, you know how to move here and there, your answer should be 2600 watt. So this is your input. Always remember, input must be greater than your useful output must be. Okay? So that your efficiency is a positive value lah. Okay? So if you do it wrongly, okay, then at the end, maybe the students sometimes they don't know, they put the upper part is a bigger value, then bottom part is a smaller value, then your efficiency will be more than 100%. Impossible, impossible. So sometimes when you do calculation for your efficiency, you ask yourself, is it this value is make sense or not? Okay, so until here, this question, what I want to emphasize is this one, rate of energy store. Actually, rate is meaning per unit time, energy per unit time. This question is asking you power. Okay, they don't want to ask you directly say that calculate the power. No, they don't want. They say rate of energy. So you have to understand by yourself. Okay, until here, is that clear? We finished chapter 6, work and power. We are going to continue the next chapter. Is it okay, dear? Zihua, okay. Angeline, okay. Okay, let me come back here. Let me have a look. Okay, this is chapter 8. Okay, chapter 8. So here we continue with chapter 9. Okay, the kinetic particle model of metals. Chapter subtopic 9.1 is about the state of matter. Actually, in year 9, year 7, year 8, okay, you learn this. Okay, solid, liquid, and gas, how their arrangement. Based on their arrangement, we can explain how is the density, how is the distance between them, is it possible to compress or not. Okay, based on their arrangement, we can explain. Okay, and then we will learn about the movement, how it moves, how was the force in between them, then we will know that why it causing the shape and volume like that. Okay, then next here, okay, we look at this is a solid.
In solids, the particles are in a fixed framework. They're held close together and vibrate.
Okay, they arrange close to each other, just next to each others, so they cannot move, they just vibrate. Vibrate.
In liquids, the particles are still in contact, but this time they're free to move around. The particles in a gas are far apart. They move quickly and randomly in any direction.
Okay, move randomly, freely in all direction, and they are very far apart from each other. This is gas. So just now the liquid is they can move freely, but they are not that far like the gas.
How do we know the particles in a gas behave this way?
Okay, how we know the particle of gas is moving in this way? This is also another topic that we will learn today. Later on, we will touch about that. Okay, so we come back to here. How the solid arrangement of the particles. So we write down together.
Arrange, close, arrange, close,
Together. Okay, how about the liquid? We say arrange slightly further apart. Okay, how about the gas? We say arrange
very far apart. Okay.
Okay, because of their arrangement, so what happened to their density? Okay, density formula is equals to mass divided by volume. Okay, in the same volume, you see solid, the particle number of particle is more. They arrange just next to each others. So at here, this mass is increased. So mass increase, density will be higher. That's why density for solid actually here we write down highest density compared to liquid and gas. So you imagine gas at here, I only have 1, 2, 3, 4, 5, 6, 6 mass only. Okay, 6 particle. So the mass at here is actually small mass. Okay, because you times with 6 particles, so actually the mass is actually low lah. So the density at here also decreases. So this one actually is the very low density. Okay, this one liquid still consider high, but solid is higher density lah. Okay, so because they arrange close to each others, solid, the particle and particle, distance between the particle almost no distance between them because they just next to each others already. Okay, the distance between them is negligible. Okay, there is no distance between them, they already touching to each other. Okay, for liquid here, you see their arrangement. Okay, their distance between the particle at here actually is very small. Okay, small. So at here we write down distance between the particle is small. Okay, so for the gas is large distance. So how I know the distance? Because of their arrangement. You see arrangement. So I know that there are large distance between the particle. So based on the arrangement, we can explain density, explain the distance, and now we explain compressible. They are just next to each other. Do you think that solid can be compressed? I'm holding my handphone. This is solid. So I compress. Can I compress my handphone? My answer is no. Okay, because they are so close to each other already. Density is high. Distance between the particle is almost no distance between them. So it is cannot incompressible. So we say that no. Okay, for the liquid is actually also no. unless inside the liquid we got a molecule, okay, a particle. So we can say that almost no lah. It can be slightly because in between still got some space lah, slightly. But overallly we can say that no, okay. So here for the gas is yes, it can be compressed. Okay, it can be compressed. So if let's say there is one piston, okay, if let's say you close this part, you're using stopper to close it, and then this is the piston part, okay, then you're trying to push it down. Inside is a molecule, you're trying to push it down. You will find that actually you can push down. You still can compress because the air molecule, they can be closer, they move closer because their space in between them still consider large space. Okay, so when we're trying to compress them, making them like nearer to each other's, they still can be compressed. Okay, so until here, finish copying the notes. Can we proceed to the movement part? Is that okay? Others not yet finished? Only Crystal okay? Okay, Angeline, Megan. Okay, if I'm too fast, you need to copy anything, you let me know. Okay, how it move. Just now the video I show you that solid because they are close to each other, just next to each other, so they cannot move. They are vibrate. This is a very important keyword, vibrate about fixed position. Keyword vibrate. Okay, vibrate. Then for the liquid, it is free to move. Okay, about within the liquid. For the gas, is move about
randomly, okay, at high speed and occupy any available space. Okay. So free to move. This one is move randomly and high speed.
oh, chemistry, you're also learning about this. Yes, dear. Chemistry, you also Licious not yet really? Okay, here. We let Licious comes to here. Okay, later on we learn about Brownian motion. Actually, chemistry maybe you will learn also. But I don't know lah because I listened to the chemistry teacher. Seems like previously is chemistry you also learn about Brownian motion. After that seems like they take it out. I'm not sure lah. Did you learn in chemistry about the Brownian motion? Did you learn Brownian motion in your chemistry? Brownian motion not in the syllabus, remove already. Yeah, they remove and they last time is actually physics we learn Brownian motion, chemistry also learning Brownian motion. If not mistaken, yeah, Angeline also mentioning remove already. So now Brownian motion is under physics part. Okay, so here because we learn about atom, how the particle and atom. Okay, here attractions force between the particle. So at here their force is very close, very strong force. Very strong. Okay, then this one liquid is strong. Then this one gas is very weak. The force in between them is very weak. For the shape of the solid, because they only vibrate and then they arrange close together, that means that their shape is fixed shape. Okay, it's fixed already. So volume is also fixed. Okay, then for the liquid, the shape, is it fixed? What do you think, dear? Shape of liquid, will it fix? Fix or not fix? What do you guys think? Any idea? For the liquid. Yes, Angeline said takes shape of container. Yes, it will follow the shape of the container. Okay, why? Because it can move freely. So they will be follow the shape of the container. So today you give like this, then it will follow. If you give like this, then it will just follow the shape. Okay, so this one is not fixed. It's because it can be moved freely. Okay, it can flow. Yes, Crystal also correct. Take up the container shape. Yes. Okay, then for the gas of course no fixed. Okay, not fixed.
It will follow, it will fill up whole container. Okay, fill up the whole
container. So if let's say you give a very big shape of balloon, then it will fill up all this part, fill up. Okay, if you give a square, then you will fill up like this. It depends, and then you will fill up all. Okay, then for the liquid, volume is fixed or not fixed, the volume. Volume of liquid fixed or not fixed? Dear, what do you think? Angeline? Crystal?
Okay, Zihua say fix. Crystal say no fix.
Answer is, it is fixed. Why, dear? Because let's say, dear, I told you, let's say this is 200 ml. I pour into another container. Here, I still get 200 ml. So the volume of the liquid is fixed. Just the shape is not fixed. Okay? Then here, for the gas is not fixed. Okay, for the gas is not fixed. Gas is depends on the volume, it depends on how big the container you given. Okay, if no problem, we will try with the past year question. Okay, 10 seconds. If let's say you haven't complete, 10 seconds. Done. If okay already, press the reaction button, let me know. Crystal okay, okay, complete already. Megan okay, Angeline okay, Licious, Hui Tong, Zihua okay, Emily okay, Licious already done. Hui Tong okay, okay, yes dear. We goes to the next page at here. Which line in the table describe the properties of solid and of liquid at fixed temperature? Okay, because at different temperature, higher temperature, solid liquid, they will be expand, okay? So now we fix the temperature. So at here, solid. Okay, you choose the answer A, B, C, D. Crystal, correct. Angeline, correct. Megan? Zihua leh, Zihua? This one should be okay, what? Okay. Solid. Volume fix. Shape fix. B and D confirm wrong. Okay. Liquid. Volume fix, like what I told you. 200 ml, you pour into another shape is also 200 ml. But the shape depends on your container. So answer should be C. Okay, next question. Question number 2. Okay, try and then tell me the answer in a gas. Crystal correct. Angeline correct. So answer is gas. Force between the molecule is very weak. Okay, because they are far away from each other's. Motion of the molecule move freely. Vibrate is only for solid. If you saw vibrate only for solid. Okay, so B and D confirm wrong. Then next question number 3. The list gives 3 properties of different state of matter. They cannot be compressed significantly. They can flow. They always completely fill their container. Okay, what is your answer? Crystal, question number 2. Do you get it? Why the answer is C? Okay. Then question number 3. Cannot be compressed significantly. Then can flow. Always completely fill their container. Zihua, you try to choose, then later on I explain. Go back to question number 2. Okay, here. Zihua, question number 3, correct? Question number 3, Angeline, Crystal, Megan. Oh, no. Dear, no. Crystal, no. Okay, answer should be A. Okay, for liquid, they cannot be compressed significantly. Yes, they can compress a little bit only. Okay, a little bit. So at here, a little bit cannot be compressed significantly. Significantly, that means very obvious. So if can be compressed significantly, that is gas. Okay, cannot be compressed, that is solid. Cannot be compressed significantly, that is liquid. Cannot be compressed, obviously, that is liquid. They can flow, liquid can flow, yes. They are always completely fill their container. For example, right now, I give a container big like this. Okay, will liquid fill up all? My answer is no. It depends on the amount of water. Here, the volume, let's say 200, maybe it's just fill out like this. It won't be completely fill up all the container. So if I give the container like this, it might be fill up like this. It's not completely fill up. Okay, so third is wrong. Third is for the gas. Okay, third is for gas. Zihua, so can you understand? Completely fill their container. This is the meaning. Only gas can be completely filled. Liquid cannot. Okay, it just follow the shape, but it cannot completely fill. So it depends on the volume lah. Okay, so question 1 and answer 1 and 2 is the correct answer for the liquid. Okay, can we go to the page number 3, question number 4? Angeline, okay? Xuan? Zihua, okay? Crystal, okay? Xuan, okay? Licious, okay? Megan, okay. Okay, then dear, we comes to here. A teacher show a class example of 3 sets of matter. They are solid metal block resting on the bench, a liquid in a gas beaker, and a gas in a clear balloon in the laboratory. Diagram below shows the arrangement in the solid. Complete the figure above to show the arrangement of the molecule in the liquid. Okay, can you show? Need to take picture. Need to take picture? Why? What do you mean? Need to take picture. I try my best is in drawing. Okay, make sure you draw in the all is similar size. Cannot be one big, one small like that. Then try to like closer together. Close a bit, but in between there is still got some space. Okay, whatever.
Okay, let me have a look. I thought the particle have to touch.
Not necessarily have to touch, dear. You see? Some of them doesn't touch, not necessarily have to touch. They're close to each others. Okay, molecule in the random arrangement, then molecule similar, almost similar distance apart from each others. Okay, it's for chemistry, yeah, maybe. So answer scheme for this past year is say that molecule in random arrangement, then molecule similar distance apart. That's all. They didn't say must be touched. Okay, this one need to draw and then show you, send to you can if you want. Okay, so here my chemistry also say need to touch. Physics no leh, we didn't say touching Okay, so the model the model answer, the answer scheme for IGCSE, they just say that molecule in random arrangement and then molecule similar distance apart. Okay, but if you want to touch, I don't mind lah. Just showing that there are some space in between them. They have some space between them. Okay. So next for the gas. Ta-da. Okay. Few particle only, and then they far away from each others. Okay, so for the answer scheme for these questions, it said that molecule in random arrangement and further apart. That is the requirement. Okay, here. In the list below, draw a ring and around the stage of matter that is the easiest to compress. Which one easiest to compress? Gas, yes. So at here, this is answer gas. Okay, here in terms of its molecule, so you have to explain what happened to molecule. Okay, in terms of its molecule, explain why this state of matter, which is we say gas. Okay, why gas is the easiest to compress. Okay, so you need to talk about the molecule. So there is a big gap between the molecule. There is more room for the molecule to move. There are gaps between the molecule. So maybe we can say there are gaps between molecules. Okay, so the force between them are force between molecules smaller compared to others. Force between the molecule is smaller. Therefore, we are easy to compress them. Okay, one is talking about the distance between them. One is talking about the force. Okay, therefore at here we say that you look at this movement arrangement, the force at here and their arrangement. Okay, so based on this, we know that they cannot be compressed. So there is a gap. There is a distance between the molecule. Molecule and molecule distance is big distance. Because the molecule are far apart, yes. Because the particle is far away from each other, yes. Okay, you talk about the distance. There is gap between the molecule. Talk about crystal, talk about molecule, because now they say molecule. So we say molecule because the molecule is far away from each others. Okay, then another point you talk about their force. Because their force in between them is small force, so we are easily to compress them.
Okay, can we go to the page number 4? Have you finished?
Okay, Megan, okay. Licious, okay. Have you finished writing it down? Licious, okay. Then let's go. Next question. Next page. Okay, change of state. This one I believe that you also know lah. Solid to liquid is a melting process. Melting process. Liquid to gas. This one is boiling, or there is another process called evaporation. Evaporation. Then from gas come back to liquid is condensation. Liquid to solid. This is solidifying. Or we say freezing. Okay, freezing. 10 seconds, complete this. Then we will do the past year question. Okay, Crystal, okay. Then we try with the past year question. This is 2023. Okay, 2023. Which statement about the particle of a substance after condensation is correct? Condensation. After condensation is correct. So choose A, B, C, D. Angeline, correct. How about others? Condensation, you ask yourself, from what to what? State of matter, from what to what? Okay, Zihua correct. So from gas goes to liquid. This is called condensation. Okay, then after that, if you're from gas to liquid, they must be close to each others. So this one, C and D far apart from each other, so this one is wrong. Okay, then after that, will it vibrate? Liquid? No, it's not vibrate, so this is wrong. So this is the correct answer. Answer should be A. Okay, Megan, correct. So at here, we go until here. Question 1, is it okay? Can we go to the question number 2? And move on. A glass contains an ice drink on a warm and humid day. The water starts to form on the outside of the glass. What is the name of the effect by which the water forms? What is the effect? What is the process happening? Angeline, correct. Crystal, correct. Condensation. Okay. So at here, the air particles surrounding at the end, they become liquid. So it's from gas to liquid. Okay. Air particles surrounding, they lose the energy. Okay. They lose the energy, they become liquid. So they form liquid at here outside. So this is called condensation. Okay, can we go to the next? Question number 3. Is it okay? Can we proceed to the page 5? Okay. Here, a particular state of matter consists of molecules that move freely in random direction. Molecule move freely in random direction at high speed. The average speed of the molecule is decreasing. Which state of matter is being described? Angeline, correct. Zihua, no. Move freely in random direction at high speed. So what is this state of matter? Zihua, no. Crystal, correct. Move freely in random direction and high speed. This is gas. Okay, speed decrease. So that means that it will be converted to liquid. Okay, it will go or it will decreasing, lose energy lah. Okay, lose energy. So at here, this one is lose energy. That's why speed decrease. Okay, so at here, this must be a gas. Solid wrong, liquid wrong. So answer should be A, cooling. Cooling is losing energy, so it cool down. Okay, so this one is lose energy. If you are being heated, is you gain more energy. If you being heated, actually the speed should be increased, not decreased. You get more energy, then you should be speed increase. Okay, is that clear? We go to question number 4. Which word is used to describe what is happening? Solid to liquid. When solid to liquid without change temperature. Okay, when phase changing, temperature does not change. Okay, for example, the ice. Okay, this is ice. Let's say this is solid into liquid. Okay, this is ice, which is the solid. We convert it to liquid, so it melt, become liquid. Okay, so at here, this one is 0 degrees Celsius, this one also 0 degrees Celsius. Temperature does not change, but they change their phase. So this process, solid to liquid, we can call it as melting. Okay, melting. Okay, next. Gas turns to liquid. Gas, for example, the steam. Okay, steam is the gas. Then it will cool down and becomes liquid. So at here also without changing temperature, 100 degrees Celsius to 100 degrees Celsius. You must remember when we change phase, here, maybe we can take notes. Change phase, temperature, without change of temperature. So here take note, without change of temperature. Okay, without change of temperature. Then here, next here. Gas it turns into the liquid. This is condensation. Yes, condensation. Okay, then when more molecules of a liquid are escaping from the surface. Oh, this one, year 9. But after that, we will learn also. A molecule escape from the surface. Do you know what is this process? Escape from surface. This is the keyword. Crystal correct. So here, escape from surface, this is called evaporation. It's only happen at surface. So keyword at here is surface, escape. Okay, if boiling is actually throughout the liquid, okay, they will happening gain the energy, so they will boil. That one is throughout the liquid. Only from surface, that is evaporation. But this one, evaporation, we will learn also, one of the subtopic. Okay, until here, is that clear? Can we go to the page number 6? Okay, here. Kinetic particle model of matter. Okay, this kinetic particle model is explain how the behavior of the material. Kinetic meaning that movement. So we know that kinetic energy is due to the movement. Okay, so kinetic at here is related to the movement. So when particle heat up, they will gain more kinetic energy. Okay, heat up, then they will move more faster. Okay, so move faster. When they have more kinetic energy, move faster. Because kinetic energy formula is 1/2 mv squared. So your kinetic energy is higher, then your velocity here, speed here will be higher. So it will move faster. Velocity is high, that means that it moves faster. The higher the temperature, the faster the particle move. Okay? As the substance cools down, its particle will lose kinetic energy and it will slow down. It will slow down. If all the particles lose all their kinetic energy, meaning that not moving, so it will stop moving. Okay, the lowest possible temperature anything can reach is, okay, so this is maybe it's a new thing for you lah. Okay, what is the lowest possible temperature in the world? Negative 273 degrees Celsius. This is the lowest temperature. Okay, this lower temperature we call it as absolute zero. Okay, absolute zero. This temperature is called absolute temperature, absolute zero. Okay, here at this absolute zero, particle has least kinetic energy. It's actually not moving. Okay, So here, on degree Celsius, this one after that we will learn change to Kelvin okay, is actually plus 273. So from Kelvin change back is minus 273. This part we will learn okay. Then at here negative 273, if we want to change to Kelvin, is actually 0K, not OK, it's 0K, because negative 273 plus 273, so you get 0 Kelvin. That's why we say absolute 0 is because of this 0 Kelvin. This is the unit of Kelvin. Okay, Kelvin is the SI unit for temperature. Why we call negative 273 degrees Celsius as absolute 0 is because of 0 Kelvin. It is 0 Kelvin. It's another scale, okay? So here, we look at the past year question at here. A student has a block of solid metal at room temperature. The student cools the block of the metal in a freezer. State the effect, if any, of cooling on the kinetic energy of the particle in the block of metal. Okay, what is the effect on the kinetic energy? Cooling. If you're cooling, what happened to your kinetic energy? Decrease. Decrease. Zihua, negative 273 is the lowest possible temperature. Angeline, reduce, okay? Crystal, move slower. Dear, energy. Talk about energy. Increase, decrease, unchanged, more, less. Move slower is describe the motion already. So it's not suitable answer, Crystal. So they're asking you what is the effect on the energy. Okay, unless they say what is the effect on the motion, movement, then you say move slower, yes. Okay, state the name of the temperature at which the particle has the least kinetic energy. Least kinetic energy, the possible temperature is negative 273 degrees Celsius. The spatial name is called absolute 0. Okay, state the value. Oh, okay, negative 273 degrees Celsius or 0 Kelvin. Okay, until here, okay? Can we proceed to the next page? Crystal, okay? Megan, okay, okay. Then here, I want to continue just now this video. Just now it's asking you how we know that gas move in this way, okay?
Some of the evidence comes from looking at how smoke appears under a microscope. Smoke from the straw is injected into a small container. A lid keeps it in place, and a bright light enables it to be viewed under a microscope. It looks like tiny jittering points of light. When a straw burns, the smoke produced is mostly bits of carbon which haven't combusted.
You see how the smoke particle move. It's actually like zigzag path. Okay, it's randomly. Why it will change direction? That is very important. We need to learn for this Brownian motion. You see the smoke particle in the air is in zigzag path. It's in a random direction. Okay.
Under a microscope, they catch the light and appear to glimmer. But why do they randomly dance around? The movement of the smoke is caused by collisions with invisible air particles.
Why it move, why it change direction is because it collide by the A molecule, A particle. So the A molecule actually is we cannot see. We cannot see. So later on we'll learn why we cannot see the A particle under the microscope. But under the microscope we can see the smoke particle moving. Then we were just showing that the bright dot is keep on changing direction, moving, and then change direction, moving, change direction. This is because there is a air particle surrounding it that we cannot see. So when it collide with the air particle, so it will change direction.
As the air particles move about, they knock the smoke first this way, then that. Particles in a gas move randomly and quickly. Flowers produce pollen, which is a very fine dust, easily brushed off by a finger. Nearly 200 years ago, it was this dust which first gave us clues about how particles behave in a liquid. In the 1820s, the botanist Robert Brown was carrying out a study of pollen grains. He decided to crush the pollen and suspend the grains in water. But to his annoyance, the pollen continually jittered around. Today, we can best see this effect by looking at tiny carbon particles instead.
It's okay like this one.
A drop of carbon...
Okay, dear, pollen grain also the same. If you put the pollen grain in the water, you will find that the pollen grain will move in zigzag path in random direction. Actually, it's because the pollen grain collide with the water molecule. Okay, so here Brownian motion is the evidence for the kinetic model of the metal. Brownian motion is the random movement of the particle in a fluid. So fluid at here is in the liquid or in the gas. So in the liquid, is related with the pollen grain, okay? Pollen grain with the water. Then in the gas is the smoke, smoke particle collide with the air particle, okay? Then after that, here, this is the setup. And here, you have to know how to draw this random movement. So you don't need to memorize. You just need to at least you change 3 direction, okay? At least change 3 times, yes, like this. Okay, simply you want to draw anyway also can. You need to draw straight line, then change direction, then straight line, change direction. You can draw any direction. You don't need to memorize the pattern. Okay, like this, like this, like this. But I will encourage you need to cross one of the line, okay, like this, whatever. Then teacher like this, yes, can. Okay. Okay, I don't want like this, curve. Or you just simply draw like this, like this, like this, like this. Teacher can or not? No. Straight line until it hits something, then it change direction. Then it will straight line again, then continue. Okay, so can you see that at here? This one is the smoke. This is smoke particle. Okay, surrounding this is called air particle. Okay, so at here we will find out that how the smoke particle move like this. This is the movement.
Okay, it will keep on changing direction. So exam, IGCSE,
they will ask you to draw the direction, how it move, the particle moving. So I want you, at least you change 3 times the direction, change 3 times the direction. And then I want you, at least you have to cross one of the line like this. Okay, don't trying like like this. Not a good idea lah. I cannot say wrong, but not a good idea. Better we give some closing to the line, okay? Then here, if we look at the smoke, okay, under the microscope, actually you can see the bright dots. Just now the video showing you the bright dots. Actually, the bright dots is the smoke particle. Okay, they will constantly move in the air at random, or we say zigzag path. So this is a very important keyword, zigzag path, to describe its motion. Okay, this is because they constantly collide with the air molecule, okay, which also moving in randomly. This effect, smoke particle will move in zigzag path in random direction. This is called Brownian motion. Okay, explain the motion of the smoke particle. The air molecule moving with high speed. Okay, it's moving with high speed. If you observe just now, you watch the video just now, air molecule is much more faster than the smoke particle lah. Okay, then after that, air molecule moving randomly. Also no specific direction. Air molecule collide with the with the smoke particle. Collision will cause what change in direction, of the smoke particle. It will change the direction of the smoke particle. That's why the smoke particle moving in this direction. Da, 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 da. Okay. Okay, until here, okay? Can we go to page number 8? Wait, okay, no problem. 子画 need wait. Okay, Liao. Okay, next. Okay, what is seen when microscope is focused on the smoke particle? So just now the video, under the microscope, what you see? Bright dots. Okay, we will draw the bright dots, which is moving in zigzag path. That's why it's very important. Zigzag path, random movement. Okay, what caused the smoke motion? Question 3, 4, 5 actually is the past year question they're asking you lah. So I just take it out. Because I saw that they keep on repeating this kind of question, so I take it out. What caused the smoke motion? Air particle collide with smoke particle at high speed, which caused the smoke particle move in zigzag path. So it's colliding. Okay, next. Why air particle cannot be seen through the microscope? So just now the microscope we saw the bright spot, that is smoke particle, but we cannot see the air molecule, air particle cannot. Why? One of the reason is because the air molecule, they're moving with randomly and they are very fast. Okay, randomly and faster because it has high kinetic energy. Then one of another important reason is because air particle is smaller, okay, and lighter, so we cannot see. Compared to smoke, it is smaller and lighter. So I go to the front page at here. You see, this is smoke. The small one is the air molecule. Some more air molecule move very fast. Okay, so under the microscope, we only can observe the smoke particle, which is the showing by the white bright dot lah. Okay, until here, okay. We got 2 minutes. We can try few MCQ. Okay, here. So you look at this. Which one is the correct suspensions of the pollen grain in water? So just like I told you, pollen grain in water also a Brownian motion. Okay, pollen grain are seen to be moving all the time. Which one is correct? A, B, C, D. Zihua, correct. Angeline, correct. Crystal, correct. Answer should be D. No curve one. They're moving in a straight line until they collide, then they change direction. So they won't be moving in curve. So curve is wrong. Okay, then it won't have in moving with random direction, random movement. So A and B also wrong. Okay, number 2. Brownian motion is observed when using a microscope to look at smoke particle in A. What caused the smoke particle to move at random? Okay. Why? Why it keep on changing direction? Zihua, correct. Why it change direction, move at random? So it will keep on changing direction. This is because it hit by air molecule. Answer is A. So Crystal correct, Angeline correct. Yes, correct. Okay, we goes to the page number 9. This one, D, small particle hit the wall. This one is will produce pressure. Okay, It will produce pressure. Pressure is force acting on the area. So it hit the wall. So this one is hit on the surface area. This is pressure. Okay, it cannot, it doesn't really explain why randomly, move at randomly. So the best answer actually is A lah. Okay, here goes to the question number 3. A student used microscope to observe pollen moving on the surface of water. Yes, pollen grain. Okay, so what reason? Why the pollen moving in this way, such way? Zihua, what is your answer? No. Angeline, yes. Crystal, yes. Answer should be C. Okay. Just now the video show you the pollen is a fine dust, right? Okay, so at here, so this one answer is here is more correct. Are moved by water molecule. Okay, the molecule collide with water molecule, then water molecule, it collide with water molecule, then the pollen will change direction. So at the end, when we observe the pollen actually moving randomly and in zigzag path. Okay. Zihua C. Okay, correct. So boys and girls, we stop our lesson at here. So next week we continue. Next week we continue. So any question? No question, then we stop at here.